Okay, great. Right, so before we get started on ggplot, we need to have the data that we'll be working with. And so these lines of code will bring that data to your computer and then read it into R for you. So this first line is a function called download.file. It goes to this URL and then downloads this file to your computer and names it data/portal_data_join.csv. If you don't have this data folder, this will not work for you. So you can either create this data folder or delete that part and it will download to wherever you are in your working directory. If you do delete this, then you need to delete it here as well. So these two paths need to match in order for you to get this data. Okay, so if I look, I see in my data folder, I have this portal data join.csv already. So if I run this read_csv function, it doesn't work because I didn't load tidyverse first. So if I load tidyverse and then run that, then I get the surveys data sets into my working environment and I see that it appears right over here. Can you please put a green sticky up when you have been able to run this line of code, read_csv, and you have a surveys object in your current working environment. Also, if you don't have tidyverse, then you can install it with this line of code, install.packages tidyverse. So again, to get this code already typed out, you can go to this URL, tinyurl.com/teachingrnew, and it will appear. Or you can type it yourself to get it downloaded and into your working environment. So you downloaded it, so that's good. But come here and then instead of survey, oh, scroll up a little bit, or is that your whole script?
That's on.
Okay, so put your cursor on line 4 and retype line 27.
There's other things.
Except do yours as survey.csv. It needs to be close, so that's, it should work unless you're in the wrong. Nope, that's perfect. And now that works. It works for him.
Okay. She said it might be an internet situation.
Is a link typed for
Let's see.
ggplot. And so if you don't, did you ever get that order?
Can you try to
to download it from there?
Okay.
Maybe that's it down. Sorry, maybe.
Internet. Okay. Yeah. Maybe try turning it off. That happens to me sometimes. When you put it on. Yeah.
Yeah. At your own fault.
It's been bad.
Really, actually, go down. Yeah. Rough last week.
No.
Well, that's fine. Thank you.
Yeah.
that HTTPS into your browser. Okay, so it's downloaded to your computer. I don't know why it's not working from R. We can troubleshoot that, but you can now read that in from wherever you saved it. So it's, I think it probably went to your downloads folder. Right. So that's fine. So go back to R. And over here, instead of data, replace that with so backspace, so the data's gone, and then put a tilde, so the squiggly line there, it's shifts. Yep. And then capital slash, and then a capital D for download. And if you press tab, it'll autocomplete for you.
can also read the link directly in with read_CSV.
No, I get nervous with the cognitive overload associated with
Fair,
that.
totally fair.
But yes, you could also, instead of giving it a path from your computer, tidyverse is really clever, this read_CSV function, and you could give it the URL directly, and it would read it directly from the internet, not save it to your computer, and put it into R, which is a little bit cleaner if you don't want these additional files on your computer. But sometimes if you've never seen this before, it gets kind of confusing, and you're like, wait, where did this magic file come from? So I had you take all the extra laborious steps. And your mental model is more decorated for it. Okay, so that we know what data we're working with, if you run str surveys, that stands for structure, and it tells you some information about this thing that we just read in. So this is a data frame or a tibble. It has 34,786 observations, and we see that we have 13 variables. They're things like record ID, month, day, year, plot ID, species, sex, time point length, weight, genus, species, taxon, plot type, because this is all ecological data. And then we see the first few observations from each of the columns are up here as well. So structure str is a good way to get a quick summary of your data. You could also do the view command with a capital V. So we see the command that I ran down here. Or if you click on surveys over in your global environment, it'll open up in this new tab within RStudio, so you can look at this like you would in Excel. So it's another way to quickly look at your data, make sure it's the right format, or in this case, get an idea for what's actually in here if you haven't worked with this data set before. Okay, so now that we have the data, we can talk about what we're actually going to be doing today. So ggplot is a really great code library that allows you to plot things in R, and that's what we're going to be working with. So I'm going to make a new divider in our document. I did that by pressing Control-Shift-R, and I'm going to call it ggplot! Exclamation point. That's not how you spell ggplot. ggplot. Okay, so it's a package where you can make really pretty plots, basically, and they can be as complex as you want them to be or as simple as you want them to be. So ggplot works in layers. So you start with a sort of a blank plot or with the data associated with your plot, and then you add things to make it more decorated or to have more features in subsequent layers. So if we want to take a look at what a ggplot command looks like, the simplest ggplot command that we can do is ggplot data is equal to surveys. And if we run this, we get a blank viewer in our plot screen. Can you put your green sticky up when you have something that looks like this? What is wrong with yours?
Still trying to figure out how to do that.
Oh, I can also put it.
No, I definitely.
So if you put your if you put your
What is my new computer?
okay, type Control-Shift-R
Is it,
all at the same time.
is it what's on papers?
And then type whatever you want this section to be called.
1 minute? Oh, that's
Yeah, it'll take a while. There's a lot of packages in it,
Yeah.
especially the first time.
Especially the internet thing.
Yeah, so it's
I
still
think
going,
it's
so
still going.
just give it a minute until it's signed. And there's still problems.
Okay, so this is a blank ggplot. So with this ggplot knows that our data surveys is associated with it, but we didn't tell ggplot how to plot our data. So all it did was give us a blank slate, and that's what we see over here. So the next thing that we want to do, our data now is bound to this plot object. So ggplot is aware that our data exists, but we haven't told it what to map or what data to put onto this plot.
So the next thing that we can do is we do ggplot again, and we give it our data. So data is equal to surveys. And then I put a comma, and then I give it the mapping. So I do mapping is equal to AES, which stands for aesthetic. And this is where I give it the data that I actually want it to plot. So I can give it my X variable, which in this case I want to give it weight. And then a Y variable, and let's give it hind foot length. So if I run this, I'm going to put it on 2 lines so it's a little bit easier to see on my screen. If I run this, we get a little bit closer to actually producing a plot. So we have weight on our x-axis because we've mapped the weight column, the weight variable in our data set to this x-axis. And then I have hind foot length on the y-axis because we did the same thing over here. We said take hind foot length from our data frame and give it to the y variable. And ggplot has automatically adjusted the axes to be in the range of the numbers that we gave it. So if we looked at the minimums and maximums of weight, we would see that the minimum weight is probably something like 1 gram, and the maximum weight is around 300 grams. Same thing for hind foot length, it varies between like 1 centimeter and goes up to about 65 centimeters. So ggplot was smart, and it did that for us and put it on, but even though we gave ggplot our data, and then we told it what part of our data we wanted to be put on this plot, we didn't actually tell it yet how we want it to plot that. So you can think we could, what are some different plot types that we have? So this is a blank plot, and we have 2 variables that are continuous. What are some ways that we could display that data? A scatter plot, yeah. Is there anything else? A bar plot, maybe? Maybe a line plot. It might be messy and it might not make a whole lot of sense, but maybe a line plot. So those are all different options that we could do to add to this plot. So if we wanted to add something to actually display our data, we have to add another layer. So to do that, I put a plus sign on the plot that we already have. And then let's make it a scatter plot because I think that was probably the most realistic one. So I do that by adding a geometry. This one's called geom point. And then we get all of our data. And it's plotted on this lovely scatter plot here. Has anybody tried to use ggplot before and gotten a warning message like this? Yeah, so this is a pretty common one. So why this is happening, if I open my surveys tab up here or by clicking on this surveys and I go over to hind foot length, we see that we have a bunch of NAs in this column. And I think if we went over to weight, yeah, we also see that there's a bunch of NAs in this column. So ggplot is telling us we have 34,000 variables. There's 4,048 for which we do not have complete cases. So we don't have observations for hind foot length, or we don't have observations for weight, or both. So it automatically dropped those out and they're not shown on the plot, but it warns us that that happened just in case we don't know. Questions about that warning message?
So if you expect there to be data in each of those cells and columns, you would have to go like, I don't know, what would be a good way to sort of like find those NAs, I guess? Just
I mean, one way that you can do it, if you don't want to do it programmatically, if you just want to see it, a quick way is to sort.
It always puts it.
And then scroll all the way down to the bottom of your 34,000, and then all of your NAs will be there. To programmatically get NAs, so let's copy this error message here so that we have context in our notes for what we're talking about. That's not really how you spell ggplot. Oh well. Automatically removes empty observations, e.g. NAs. So one way to programmatically remove NAs we're going to use the library dplyr. So if you already ran library tidyverse, then you don't need this line of code. But if you didn't, then you would need that. So let's filter out all the NAs that are in. So do you want to filter them out, or do you want to actually see them?
I guess either way, I guess to see them was my first thought.
Okay.
In terms of, like, why this exists.
And then we'll filter them out second. Okay, I think the way that I would do this is by using subsetting. There's probably approximately 10 ways that you could do this, but if I wanted to see all of the hindfoot lengths, or all of the weights that are NA. I would take my surveys, I would type it to filter, which is a dplyr command, and then I would do is.na weight. So if I run this, I see that we get 2,503 observations. And if I open this up and scroll over to weight, everything in here has an NA. If we wanted to filter out a bunch of NAs from our data set, we could do sort of the opposite. So we'd take surveys and pipe it to filter, but instead of is.na, which selects the NAs, we would do an exclamation point which negates the selection, and do is.na of weight, is.na of hindfoot length, oops, and is.na of sex. And now I see that brought us down to 30,000 observations from the 34,000.
Now you shouldn't expect to see that warning, right?
Let's check it. So now if I do ggplot surveys complete, how do I, so that's my data, is surveys complete. How do I tell ggplot where to look inside that data frame? What argument do I use? Mapping. Mapping is equal to, and then I use the function aesthetic, and I give it an X, and let's say, what was it? Weight. And then, sorry, I'm going to put this on a new line. Y is equal to hindfoot length. And then what do I need? A plus point. Yes. So our plot looks exactly the same, but now we don't get a warning message. Questions about that?
So mapping, is that necessary to write mapping? I feel like I've never used that particular.
If you don't write it, but you keep your ggplot command in this order, it's implied. So I almost never use it, but I think that it's nice for when you're first learning, because I'll explain more later. Yeah, so you don't need the argument name, but if it's explicit, then it can add some context to what's going on. Okay. Did everybody create the surveys complete, or do you still have surveys? Okay, we will continue plotting with surveys. And do we feel comfortable with that warning message now? Okay, because we're going to get it a lot today. Let's continue plotting with surveys. Okay, so right, so there's other ways that you can sort of exploit the fact that these things are created in layers. So we've just been plotting this and not saving this as an object at all. But we can also save our plot as an object. So let's call this surveys plot. And we'll do ggplot. Data is equal to surveys complete. Mapping is equal to AES. X is equal to weight. Yep, sorry. Thank you. Okay, so if we run this line of code, surveys plot, our assignment arrow, and then our ggplot command, what this will do is save that semi-blank plot that had our axis information into an object. So it's going to remember these bindings, these data bindings to the plot in an object called surveys plot. And then what we can do is use this object, surveys plot, and our plus sign to add a layer to that. So we can do plus geom_point. And this still works as well. So we have our surveys plot, and that was the blank plot. We saved it to an object, and then we added the geometry for points to it. So this can be handy if you need to, if you want to save your plot to an object, or it's just another syntax that you can use and build your plot object like this instead. Okay. So let's start building on this plot iteratively to make it better. I sometimes save my plots to objects, but most of the time I don't. I'm not going to use this surveys plot object. Okay, so ggplot. Data is equal to surveys. Mapping is equal to aesthetic. X is equal to weight. Y is equal to hindfoot length. Our plus sign at the end. And then geom_point. And this is our first little goodie that we're going to add to the plot. Inside of geom_point, I'm going to give it the argument alpha and put alpha equal to 0.1. And if I run this, we get our same warning message, but that's okay because we know what's causing it. And it's probably the least apparent on my screen, but what change happened here? Can anybody see? We impacted the transparency of our data points. Can anybody see, can anybody describe to me how we impacted that transparency from looking at this line of code?
Looks like each point is 1/10.
Exactly. So each point is 1/10 of the full color weight. And so what's nice about this, I'm going to zoom in on this plot. What's nice about this is when there's 10 points overlapping, it's fully colored. And when there's one point by itself, it's 1/10 of the color. So this allows us to start seeing the, oh crap, the word, thank you, of data and how the points all overlap on the graph. So let me escape out of this. Oops. Okay, so that's nice. What if we also wanted to change the color of this? If I do my ggplot, data is equal to surveys, mapping is equal to AES, X is equal to weight, Y is equal to hindfoot length. And then we do geom point again. I still want the alpha, the transparency, to be set to 0.1, but now this time I want the color to be blue. So I'm going to do color equals blue, and the blue has to be in quotes, because this is a description of the color that I'm using, not an object that's in our global environment. So if I run this, the whole plot changed and now it's blue. Okay. That's not really a useful use of color though, because even though blue might be pretty and nice to look at, it doesn't tell us any additional information. And in general, when you're adding something to a plot, you want it to add information to your plot. So instead of hard coding the color as blue, we can set the color as something like species ID. So this time I'm going to do ggplot. My data is still equal to surveys. My mapping is still AES, aesthetic, X is equal to weight, Y is equal to hindfoot length. I'm still going to add geom_point to make it a scatter plot. My alpha is still going to be 0.1. But this time, to do color, I'm going to do AES for aesthetic. Color is equal to species_ID. So species ID is another column inside of this data frame surveys. And now if I run this, and make it bigger, my blobs are now colorful. Yay. Okay, so what changed here? Between these two plots, when we added color, and the first one, color is inside of these parentheses for geom point. Color, when we're giving it the variable species ID, is inside of the aesthetic. Whenever you put a variable inside of the aesthetic, you are telling ggplot that it contains data that you're actually wanting to represent. When if something is outside of the aesthetic, like alpha is here or color blue is up there, you're hard coding those features on your plot. So for example, the alpha over here is 1/10, is 0.1. That allows us to see the density of data, but that doesn't actually encode any information from our data frame. We're just saying every point needs to be 1/10 the full color that it could be. But when we're giving it the color of the species, that's something that's from our data frame. So it needs to be inside of the aesthetic, and then we get things like a legend and all of those sorts of things because it's changing the data. The color now encodes data about our data frame. And that's why also weight and hindfoot length are inside of the aesthetic in this first layer of our ggplot, because these both encode data that we see on our plot. Questions about that?
Well, does it matter where you put the AES? I mean, I'm just wondering why do you have the first one inside ggplot and then the second one inside geom point?
Yeah.
And does that matter?
Yeah, so the question is, does it matter where we put the data inside of which aesthetic? So in this case, no, it doesn't. Because if we had put color inside of here in this first aesthetic, geom point would have inherited that and done the color just like it is. But what this is doing is if we put data inside of the aesthetic at this layer, that's inherited in every subsequent layer. If we put it in this layer, it only encodes data for this layer. Yes.
So if you want to specify some, let's say you have like 33 species, and one is like red, green, yellow, can you specify like this species can be red?
Yes, you can. I'm not going to do it because we have 33.
I know.
So let's see. To add specific colors for your data, you would add a layer scale color manual. And then you give it the values. So you'd have to know the order of your colors. I'm going to demonstrate this with a different data set. So iris is a data set that's built in to R, so everybody should have it. If you run view iris, we see a data frame of petal lengths and species and that sort of thing. And the reason I'm using it is because there's only 3 species in this column: variccolor, setosa, and I think virginica. Yes. Okay. So I can ggplot iris as well. So if I do ggplot, data is equal to iris. And then I'm going to use the shortcut and not give it the mapping name, but just aesthetic. X is equal to sepal width. Y is equal to sepal length. I have to add a layer. Geom point. And then aesthetic color is equal to species. And then a plus sign. And if I want to control the colors, well, let's run this first without controlling the colors. I'm going to delete that plus sign and run this. I see that we get the default ggplot colors, setosa, variccolor, and virginica for these species, and they're on this plot. If I add a plus sign and now I want to change these colors, so I'm now going, instead of red, green, blue, I'm going red, blue, green. These automatically inherit from the order of the species that you have here. So red is going to correspond to setosa, blue is going to correspond to variccolor, and green is going to correspond to virginica. And if I run this, I now have the base R colors, which are very ugly, and they're different, but I have them red, blue, green. There's a way to set them specifically for each one. Do you remember the syntax for that? Is it like this? Let's try it. This could be wrong. Yep, that works. So if you don't want to use the automatic encodings and you want to be very explicit, you can type it out like this, where you say which each species is equal to which color.
Can you scroll to the left?
Yep, sorry. So the command is scale color manual.
Within aesthetics, you can also, color by species, show you different colors and automatically picks from a list of colors or something. But can you change that sort of like list of colors?
Yes. Okay, so this is how you would like manually set the colors. Like let's say you have your favorite hex codes or something. You can do it like this. If you don't have your favorite hex codes and you just want to change the colors, there's a package you can install called library color or R color brewer. So you can do install.packages to get that one. And if we do they?
Because color brewer is one of like Beardist and color brewer are now some default.
Okay, let's try it. I'm gonna copy and paste this, and I'm sorry, but I'm just gonna do it. So I copied and pasted this plot that we had, the aesthetic of color of species, and this gives us sort of ugly colors. Let's take a look at them. Oh, this is fun. Has anybody seen this error before and been like, but my code works and it's always worked. Why am I getting this? Error in grid.call.graphics. cannot pop the top level viewport, in addition, warning messages. Basically what that's saying is that this pane was too small for it to be able to produce the plot. So even though my code was totally fine, it couldn't show it to me, so it's gonna give me an error, which is a super confusing error message. But I made my plot pane bigger, and now it's loading the plot. So these are our ugly colors. Let's add a layer to make them cuter. If I do scale, color, brewer, oh, it does come. See, the reason that I know that this comes in ggplot2 instead of in the R color brewer package is because this little grayed out thing in my tab complete, where it has in braces ggplot2, tells me that this function was imported into our global environment by the package ggplot2. So I didn't need to load our color brewer. ggplot2 took care of it for me. And I know that it's coming from ggplot2 because it tells me that that's the package that it came from. Thanks, Michael. I didn't know that. Okay, so scale, color, brewer, and then let's set a palette. So palette is equal to set1. And this is going to give us a different set of error messages, but that's okay. We'll just keep rolling with it. So I know the names of the R color brewer packages. We can Google them and take a look at them. But set1 only has 8 colors in it. And so we have way more than 8 species. So it says warning messages in our color brewer, brewer pal, and pal. N is too large, meaning we have too many things, allowed for the maximum palette size of set1, which is 9. Returning the palette you asked for with that many colors. So it plotted the first 9 of my species, and then it just stopped plotting the rest of them. I just tried to press zoom, and I don't know where my plot went. There it is. And it just so happens that the first 9 of our species don't really have that many observations. So this is the only data that we got on our plot. So the most number of colors in a default R color brewer package is 12. The most in other palette packages associated with ggplot is 20. So if you have more than 20 observations in your data, color is not the best way to visualize it. In general, if you have more than 12, color is not the best way to visualize it. But you can kind of get away with that if it's less than 20.
You know,
yeah, paired in our color brewer has 12. And then Tableau 20 has 20, but I think you need to download. Michael, is Tableau in our color brewer? I think you have to download GG themes to get the Tableau 20 palette.
If you Google like R color palettes, you'll find like tons of info on like you look like there are lots of different lists of packages. Like different packages that give you colors from Wes Anderson movies.
Yeah.
Like color palettes. There's a ton of stuff on this.
Yeah. Okay, so I did paired, and now we see we got more information because there's slightly more colors in this palette, but we don't get that much more information. Okay. Questions about that? Great. Okay, so do you guys want to do a challenge question now, or do you want to keep seeing more ggplot information and do challenges during like the second hour? Okay. Cool, got some nods. Great, so let's learn how to do other geometry. So I'm gonna come down here. We're gonna keep working with the same data set. So I'm gonna start using the notation that you'll see most of the time where people don't say data or mapping, but it's assumed that you're talking about the data and mapping because we're keeping it in the same order. So we're using the surveys data, and now in our aesthetic, we're gonna do X is equal to species ID, and Y is equal to weight. And now because this is a different type of data, where species ID is a character that has a certain number of levels associated with it instead of being a continuous variable, and weight is continuous, we're going to use a different type of geometry. We're going to do geom box plot. And if I run this, we get a box plot. And this is a much nicer way to visualize the distribution of weights within our species. If you were to zoom in on this a little bit, I think that your your x-axis labels would be much more nicely resolved than mine are. But box plots have often been criticized because they obscure some of your data from you. So when you look at this, it's assumed that you know that all of your data is captured within this distribution and only the outliers are plotted. And that can be a little hard to remember or difficult to interpret. So we can add our plots directly to our, add our data, the points directly to our box plot. So we'll do surveys, aesthetic is equal to species ID again, and Y is equal to weight. We'll add a layer. We still want our box plot because box plots are fun. And then we're going to add an additional layer where we jitter our points. So if we do geom jitter, and we give it alpha is equal to 0.3, and color is equal to tomato. Just gonna make this bigger. Now we can at least sort of see all of our data points. How could this plot be improved?
To make the jitter maybe less wide.
That's a great idea. We're not going to do it. I think that's with a width argument in here. You can control that. What's another way you can improve this plot? That's another great idea. We're also not going to do it. I think that's with a size argument. You could give it like size 0.1. More ideas.
I would put the box plots on top of the
Yes.
points with no fill.
That's the one that I was looking for. So let's do the same plot, same exact code, but just change the order of the layers. So let's do surveys, AES, X is equal to species underscore ID, Y is equal to weight. Plus sign to add a layer. Let me make this smaller, sorry. And then we'll do geom jitter first. So our points will come onto our plot first. And I'm gonna do alpha is equal to 0.1, but otherwise keep it the same. And color is equal to tomato. And then another plus sign and do geom box plot. A lot of points, takes it a little while to load. Okay. So now you can see the box plot distribution. The outliers are plotted, but you can see your points also behind this and a little bit more of that distribution. Yes.
So different box plots have different like implicit sort of structure, right? Like the percentiles and so on.
Yeah.
What's the best way to like you weren't sure what this one is like get at the goal group?
That's a great question. Yeah, so for people remote, the question is different box plots might have different implicit ideas about what a distribution is or like what the percentages of cutoffs and that sort of thing is. So how would you figure that out? If I put a question mark and then geom box plot, and I can do parentheses or not, and press enter, the help file for this comes up. And I can see the description for this. It says box plot compactly displays the distribution of continuous variable, outlying points, la-ti-da. Let's see. 10 points to whoever finds the information in this help file first, because it should be there. There. The upper whisker extends from the hinge to the largest value no further than 1.5 IQR from the hinge, something, 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 not
notches extend 1.58 times IQR divided by the square root of n. This gives a roughly 95% confidence interval for varying medians. So in general, the assumptions of the different layers that you're adding to your plot should be in these help files. Something else I want to show, if you start typing geom, one really nice thing about almost all of the functions in the tidyverse is if there's related functions, so all of these functions add data to a plot. They all start with the geom underscore prefix, which means that if you forget your favorite geometry that you want to add to your plot, you can type geom underscore, press tab, or just wait a second, and then all of your options will pop up. So there's a lot of different geometries that you can add to a plot to make it look the way that you want it to. And you don't have to remember all of them because they're all right here. Whee! I'm going to steal the thunder of one of the challenge questions. Let's see about there. And show another, what I think is a better way to look at this data. So if we do ggplot of surveys, AES, X is equal to species underscore ID, Y is equal to weight. And then we'll do geom violin. That's not how you spell violin. There we go.
You saved the code.
Yes, sorry, thank you. There's a lot of species on this plot, so it's not the prettiest representation that I ever did see, but it is kind of nice. So what a violin plot does is it shows you the distribution like a histogram would relative to this y-axis. So for each of our different species, we get this histogram. And instead of being one-sided, it makes it pretty and does it two-sided. And they sort of end up looking like violins, which is why it's called a violin plot. So this is another geometry that you could use in ggplot to make the plot that you're interested in. There are a bunch of questions at the bottom of this document that I will leave up. Some of them are goodies, like this hexbin package. If you try and run it, it does fun things. And then some are just to practice the things that we just learned today. So if you don't have anything to do in the next hour and you want to work on that, we can come around and help answer questions. Next week, we meaning Ryan, will go over plotting time series and faceting your data. And then the week after that, I think we'll go more over like customization and colors and arranging and exporting plots. So if you can come, we'd love to see you. If not, we try and record and post everything on the website later, so you can use this as a resource. Any questions? Or what questions do you have? Cool, thanks for coming.